Hello world, Noah here. Welcome to the lab component of the variables lesson of CS University. In this lab, we're going to get some more practice with variables, with the stuff that we learned in this lesson. I have two exercises that we're going to go through. One is going to be more practice with declaring variables. Then the other one is going to be more practice with the type function and just determining the type of a variable in general. So let's start with the first exercise here. I have 4 different scenarios, and for each one we want to create some sort of a variable to sort of represent that scenario. And remember, the syntax for a variable is the name of the variable equals the value. So name equals value, right? And the type isn't part of the declaration. You don't have to say, oh, this is an integer, or oh, this is a string, because Python is smart enough to know that. But again, it's a good thing to keep in mind. And so for each of these examples, we'll actually think about the name and the type in addition to the name and the value. So let's look at the first one. A player has 10 points in a game, and we want to represent this in a variable. So we have a game, and we want to keep track of the number of points that the player has. Obviously, it's a piece of data that's important to a game, so it belongs in a variable. We need 3 pieces of information. We need the name, we need the value, and we need the type. And again, the type is just, we're just thinking about that so that we know. And also you'll remember that since all of these lines start with hash signs like that, it means that they are all comments, and so this isn't actual code, but we'll go ahead and write some actual code right now to declare the variable. First, we want to consider, what will name, value, and type be. So, okay, if this is some sort of a game, the player has 10 points. So this sounds like it's the player's score. Whoops. And so I'd say score is probably the best name for this. We're keeping track of the number of points the player has. That's their score. So the name is score. The value is, of course, going to be 10 because, that's what we're given. We're given that they have 10 points, so the value is 10. And what type is it going to be? Well, to determine the type, you just look at the value. You say, okay, it's a number, it's a whole number, so therefore it's an int or an integer. Right? And now in order to declare it, very simply, we say the name of the variable, which is score, is equal to the value of the variable, which is 10. So score equals 10. We have this variable, the name is score, and the value is 10. Nice and simple. So just to show you, I'm going to go ahead and save this and hit F5 to run it. And you'll notice that nothing happens, right? We made this variable here, but it didn't seem to do anything. And that makes sense, right? We made this variable, we never actually used it anywhere. And so the variable exists, and then the program ends, and we never did anything with it. Just to give you a little bit of an idea as to why variables may be useful, what you can do the same thing that we did in the last lab, which is to print it. So print, and then in parentheses we're going to write the name of the variable, but we're not going to write quotation marks. And that'll become more clear later, but just be clear here, we're writing the name of the variable, which is score, without quotation marks. I'm going to save this, and before I hit run, imagine what it might print out. And it printed out 10. It's probably what you guessed, right? So basically the idea here is we said again, a variable is a symbol that basically represents a value. And so we have this number 10 here. It's the number 10. It could mean anything. It could mean a million different things, right? But we have this variable called score. It represents the score of the player. And so when we say we want to print out whatever the score of the player is, well, it's going to say, okay, score. Well, the score is equal to 10. And so when I'm printing out the score, it's going to print out the number 10, right? Because score is just a symbol that stands for the number 10. And just to be clear, if this were a different number, like let's say 11, and I ran this again, it would say 11, right? And I think that should be pretty clear. So the idea is that all of these variables are basically symbols that represent values. They give meaning to this value. So 10 could mean a million different things, but here we're saying it means the score. And then you can use this symbol, you can use this variable later on to reference the value that it's equal to. So later on, I could put this, somewhere else. I could put this down here if I wanted to. and it would run the exact same way. It would print 10 again, right, because score is equal to 10. Basically, the idea is, that we're just referencing this variable. We're referencing the value that this symbol, that this variable has. Okay, so let's look at the next example. Bakery charges $1.50 for a cookie. Okay, name, value, and type. What are they going to be? Okay, so the name. Now, okay, you could get you could get very simple here. You could get a little bit more complicated. It really depends on what sort of application you are writing. So it could be something as simple as cost. It's the cost of something. It's not very specific, but if it's a bakery that only sells cookies, then maybe that's good enough. You could name it something like cookie cost. And again, in Python, we use underscores when we want to have multiple words in a variable name. So cookie cost, again, that's pretty clear. How much does a cookie cost? I wouldn't get any more complicated than that. I think cookie cost is probably the best name because it's pretty short, but it tells you exactly what this variable represents. So what's the value going to be? So if the cookie costs $1.50, we're going to write 1.5. You could write 1.50, but the 0 isn't necessary, right? Because it's just a number, 1.5. We're happening to say that it's a dollar amount, but when it gets represented in Python doesn't know what dollars are, and so it's just a number with a decimal place. And that should tell us what type it is. Again, it's a number with a decimal place, which means it is a float. So just to keep in the back of our minds that it's a float, we don't actually need to tell Python that it's a float because it can look at 1.5 and say, okay, 1.5 is a float. But anyways, we use the same old formula, name equals value, name equals value, nice and simple. We've created this variable called cookie cost, which is equal to 1.5. And then again, later on, if I, printed out cookie costs like that, and I run it again, it'll say 1.5, which is exactly what we expect, because once again, cookie cost is a variable or a symbol which represents this value. And I think that point is clear. Let's do the next one. A user with email address ilovecode@email.com logs into their account. So we want to basically represent this email address in code, all this stuff right here. So the name, what's the name going to be? We could just call it email. You could call it email underscore address if you want to. I think email's clear enough. It's someone's email address. What's the value going to be? So it's given to us this ilovecode at email.com, but we need to make sure that we put it in quotation marks, right? Because it's a sequence of letters, numbers, and symbols. And so it belongs in quotation marks. And that should tell us anything in quotation marks is always a string. Right? So a string is a sequence of letters, numbers, and characters inside of quotation marks. And so you can say, okay, if this is a string, it must have quotation marks. Or if this is in quotation marks, it must be a string. So that should be pretty clear. And okay, so it has to be in quotation marks because, we have these letters and whatever, and it's basically a word or a sequence of characters, and so it's a string. And so to declare it, again, we do name equals value, and I'll keep the leet speak like that. So just like that, email equals that. And you'll notice that it's highlighted in green because idle recognizes that it's a string. And it's just going to highlight strings in green, just like it highlights comments in red, just to help us sort of read through the code quicker and see where different things are. So the last one that we'll take a look at, 3 people play rock, paper, scissors. Nick throws rock, Brian throws paper, and Vahan throws scissors. So we have 3 people, and each of them has a move. So we'll represent them, in variables. And we can do this on 3 different lines, or we could do this using multiple assignment, which is something that we talked about very briefly in the lecture. So let's just do it the classic way first. We'll just name these variables Nick, Brian, and Vahan to make it, simple. And we'll name them with lowercase letters because in Python we like to name our variables using all lowercase letters. And then the values will be rock, paper, and scissors. And since they are words, they're sequences of letters, they have to be strings, right? And since they're strings, we need to have quotation marks around rock, paper, and scissors. So we could write something like Nick equals rock, Brian equals paper, and Vahan equals scissors, just like that. And that's pretty simple, right? So the variable Nick is equal to the string rock, which represents that Nick threw rock in this round of rock, paper, scissors. What we could also do is we could do multiple assignment. We could say Nick, Brian, Vahan equals rock, paper, scissors. And again, the way that this works is the first variable gets matched up with the first value. The second variable gets matched up with the second value. And the third variable gets matched up with the third value, just like that. So, instead of having 3 different lines, you have, one line with everything. But then again, you can do that, and this also looks pretty nice too. So you don't need to do multiple assignment ever, but it can be a nice thing to do. It can make your code look a little bit cleaner. So I figured I'd just give an example of it. But hopefully now you have maybe a better idea of declaring variables. Maybe you feel a little bit better about it. But it's really, really simple, right? You just have a name, a value, and then a type that you sort of want to keep in mind, but you don't actually have to write it. And then you just do name equals value. And again, the name should sort of describe briefly what the value represents, and then the value is the value that you're trying to store, clear enough. So let's take a look then at the next exercise, which I have hiding down here. And the next exercise is going to give us a bunch of different values, and it's going to ask us what are the types of the following values. And you'll notice that there are sort of 3 different sections, and they all look really similar, but perhaps they're not really similar. And this is actually somewhere where our shell over here can come into play, because like I mentioned really briefly when we were setting it up, the shell is great for just testing little snippets of code. And so that's really all we want to do here. We want to figure out what the types of all these variables are. And so that's really, it's a one-line thing to do to check each one. And so we can sort of use the shell to experiment. When we start actually writing our code, like up here we were creating these variables, so I wanted to write it in the code. But over here we can, use the shell to sort of experiment with it a little bit. Before we, jump into using the shell, let's actually try and think through these. So the first one, we have these 4 different values here. It's the number 10, but we have 10, 10.0, 10 in quotation marks, and 10.0 in quotation marks. So will they all be the same? Will they all be different? Who knows? So let's start with the first one, which I think should be pretty easy. Whoops, I don't know why that just happened. Anyways, let's start with 10. So what is 10 going to be? Well, we see that it's a number, and we see that it is a whole number, right? There's no decimal place at all. And so we say that 10 has to be an int. And that should be pretty clear. How can we test this? Well, we can use the type function, right? And then in quotation marks, or sorry, in parentheses, not quotation marks, but in parentheses, we put the thing we want to check the type of. So we're considering this number 10. So we're saying, what is the type of 10? And when we run this, it says it's an int. So we were right that it's an int. How about the next one, 10.0? So you can look at this and say, okay, well, it's the same number basically, at least as far as math is concerned, it's the same number. There is this decimal place here, but it's sort of still a whole number, right? Because it's 0.0. Well, in Python, as soon as you see this decimal place, that will immediately tell you that it is a floating point number. And so when you see 10.0, it's going to be a float because this decimal place is here. And this could just as easily have been 10.5 or 10.2. It just so happens to be 10.0. But you can see it would be a little bit confusing if 10.0 were an int, but then 10.1 were a float. So Python says if you're going to put the decimal place, it's going to be a float. And just to sort of look at it, we can say what's the type of 10.0? It's a float. So 10 is an int, but 10.0 is a float because of the 0.0. So even if 10 and 10.0 are sort of the same to us, they're a little bit different to Python. How about this next one? It's still the number 10, but now it's in quotation marks. So does that change anything? Well, yes, it does. What we said before was that anything that we see that's in quotation marks is automatically a string. It doesn't matter what's inside of the quotation marks. As soon as you see quotation marks, you should immediately know that it's a string. Because this could have easily been something like $10 or, $10 or whatever you want it to be. It could have easily been anything else, because when you have quotation marks, you can put letters, numbers, and symbols inside of it. And so just to test it, we can do, caps lock. We can say, what's the type of 10 in quotation marks? And we can see it is a string, right? So even though this just so happens to be a valid number, it's in quotation marks, and so it's a string, because it could just as easily have been, something else. It could have easily been something that's not a valid number. And this last one, 10.0, well, again, it's in quotation marks, and so, it has to be a string. And again, we can prove that by saying, what's the type of 10.0? It's a string, right? And this, once you understand why this is a string, it should be clear why this one is a string, because of the quotation marks. So the takeaways from this first example is, okay, here's a whole number, pretty easy. As soon as you see the decimal place, it's automatically a float, even if it happens to be 0.0. And then as soon as you see quotation marks, it must be a string, even if it just so happens to be a valid number in quotation marks, or a valid, float number in quotation marks. It could just as easily have been something invalid, and so we say that it's always going to be a string, because we like consistency. So that example should be clear enough. Let's take a look at the next one. We now have the word hello, but first we have it with no quotation marks, then we have it with double quotes, and then we have it with single quotes. So let's start with this first one. What type of value is hello like this? Well, first you'll notice that it's black, and maybe that's not too helpful because so is the 10 and the 10.0. But if you go back up here and look, and maybe colors aren't the best way to describe it because it's code after all, and the syntax highlighting is just here to help us. But the basic idea is that when we say hello like this, we're trying to refer to a variable that's called hello. So like back up here at this example, when I said something like print score like that, and you'll notice score is in black and there's no quotation marks around it, I'm saying I want the variable. I'm referring to the variable called score. And then Python can say, oh, here's a variable called score. It's equal to 10. And so it's going to print out 10, of course. If I run this. Or I guess it'll actually give us an error first, which sort of gives away that answer, but that's okay. If we run it again, you'll see it says 10, which is what we expect. But basically the problem here, and the reason why we got that error message that we got, is because when I say hello like this, it's referring to a variable called hello, but that variable doesn't exist, right? And so, this won't work. And you can see it gives us an error. It's saying name hello is not defined, right? There's no variable called hello. And when we write hello in without the quotation marks, we get an error message because it's not defined. So that should be pretty clear. How about this one, hello in double quotes? Again, we said whenever we see something in quotation marks, it must be a string. And just to prove it, if I do, I think I'm hitting the wrong key on my keyboard. If I do the type of hello, it's a string. And how about this with the single quotes? Well, as I said in the variables lesson, you can use single quotes or double quotes. It doesn't matter. And so the fact that this is in single quotes, it will still be a string. So type of hello in single quotes. Whoops, I hit enter too early. Type of hello in single quotes is a string, just like we expect it to be. So the basic idea here is if you're not using quotation marks and you're using a word like hello, you're referring to a variable called hello, and that's not what we wanted to do here, so we got an error like this. And when you're using a string, you can use either single quotes or double quotes. It doesn't make a difference at all. How about this last example? We have true and true. So first off, we have true with a capital T. We can see that it's highlighted in orange, so Python knows that it's something special. What type is it going to be? It's a Boolean, which is what we expect it to be. Remember, a Boolean or a bool is a true or false value, and we said capital T true and capital F false are the two possible values for for a Boolean. And so, just to give the demonstration, type of false is also bool, because those are the two possible types that a Boolean could be. So this is a bool. Oops. And how about this one? This one should now be really easy, but I just want to drill this in because this is something that my students did struggle with at various points. Right, we see quotation marks. Just because this happens to be capital T true, there's still quotation marks there. And so if I say, what's the type of true in quotation marks, it's going to be a string, because anything in quotation marks is a string. And so this is a string. And so the takeaway again here is don't make a mistake with quotation marks, because if you stick true in quotation marks, it'll be a string. Maybe you want it to be a bool. In the same way that if you put 10 in quotation marks, it's a string, whereas maybe you want it to be an integer, or 10.0 is a string and maybe you want it to be a float. So that's basically the idea here. We got some practice declaring variables, which is obviously very important, and then we also got some practice with the variable types. These were some trickier puzzles that I could think of, but they're really important because this is something that a lot of beginners will struggle with. Just because these things look really similar and the rules may seem arbitrary, but it turns out they're actually not, and they actually make quite a bit of sense. So that's all for this lab. Hopefully variables make more sense. They're never going to go away, so you will get plenty of practice in the future declaring them. But in the next lesson, we'll learn some more code, and I'll see you guys there.